All right, so like I said, your notes should look like this because we are talking about density. So the first thing, this first slide. So these three things, these 3 boxes of Cheerios, these 3 rolls of quarters, you know, this gold bar, they have about the same mass, but they have much different volumes. They're different sizes because they have different densities. The materials that they're made out of have much different densities. 3 boxes of Cheerios that make up, a kilogram worth of Cheerios takes up a lot more space than this little gold bar that has the same mass. This first one, this is just a definition of density. So, again, with these notes where you have these blanks, you can click the text box and fill it in. The definition of density is the amount of mass in a given volume. So with these two, with this example, these two cylinders, the one on the right would have a greater mass and a greater density because there's more stuff in it. It's the exact same size as the one on the left, but there's more stuff in it, so it's more dense. You kind of think of it like if you have 2 trash cans, in one of them you just put a few things in there. It might be full, but you aren't really, pushing down or anything. But this one, you're pushing stuff in there, you're standing on top of it to get as much stuff in there. It's going to be much heavier because it's much more dense because you pack more stuff in the same volume, in the same size. So that's just kind of the plain Jane definition of density, just the mass in a given volume. Just like with this one, both of these objects have the same mass. That's why they're balanced, on the balance, because they have the same mass, but they have different volumes. The one on the left is, much, much larger than the one on the right. So the one on the right is more dense, has a greater density, whatever it is that it's made out of. The red stuff that it's made out of is much more dense than the blue stuff that this one's made out of. And at any time, as I'm going through this, if you need me to, jump back a slide or go over something else, just let me know. Okay, this is the formula for density. So density equals mass over volume, or mass divided by volume. And then because of the wonders of algebra, if you know any 2 of these 3 things, then you can find the other one. We won't have to do that today, but it is doable. But you might want to, I don't know, put a star or something next to this. Just it's an important formula to know. All right. If we're talking about units, so when we're talking about density and measuring density, the units that we use for solids is grams per cubic centimeter. So if you have 1 cubic centimeter, a little cube with 1 centimeter on each side. If you have 1 cubic centimeter, what's the mass in grams? That would be the units for that as a solid. If we're talking about liquids, we're talking about grams per milliliter. So if you have 1 milliliter of that liquid, what's the mass in grams? Cubic centimeter, and maybe you've heard this, if you're watching TV or movies or whatever, and there's something in like an emergency room, they say, I need 5 cc's of something stat. Saying cc's is the same as cubic centimeter, which if you have 1 cubic centimeter of water, that's the same volume as 1 milliliter of water. So they're the same volume wise, but cubic centimeters is more of a solid measurement. Okay, on to the density of water, which is a nice thing. If you have pure water, nothing else in it. Go ahead. Go ahead. Okay. I can't hear you. Malachi, do you have a question? I guess not.
Wait, what'd you say? Sorry, Mike.
Did you have a question?
Yeah, I
I,
said, mm,
I couldn't hear it. I'm sorry.
oh, okay. So can you go back a slide? I forgot the liquid part. Yeah. Gee. Okay.
Okay. All right. So the density of water, like I said, if you have pure water, the density is 1 gram per milliliter. So if you have 1 milliliter of water, it's pure water, is going to have a mass of 1 gram. If you have something with a density less than 1, so density less than pure water, it'll float in water. So something less than 1, if something has a density less than 1, it floats. Can anybody guess what happens if the density is more than 1?
It goes down.
Right. So if it's
Sinks.
more than 1, it sinks. Good. So one of the kind of strange things about water is when it freezes, water expands a little bit. Like if you've ever, put a drink in the freezer to get it cold faster, and you forgot about it and left it in there too long, it's possible that it could even break the container or deform it some way because water expands. When water expands, it becomes less dense, so it floats. So that's why ice floats, even though it's water. Most solids are more dense than in their liquid form, but ice and water is different, so it floats. So we have this thing. I usually do this demonstration in class. It works with Pepsi and Diet Pepsi, or Coke and Diet Coke, or Dr. Pepper and Diet Dr. Pepper. Anything where you have a regular carbonated drink and then a diet version. But the regular one will sink, just like the diet one will float. To have the little clip here. Oops. There we go. And you can try this at home if you have, the regular and diet version of some drink. It should work. So because of all the sugar in it, it makes it more dense compared to, so it sinks, and then the diet version doesn't have all the sugar in it, so it's less dense, so it floats. I just like the music. But like I said, it does work. So I mean, you can try it. I mean, I've done it many times. It does work. Another example, kind of with differences in density: salt water and tap water. And eventually, these two would mix. Given enough time, they would mix. But for a while, they'll stay separated. But because the salt water has salt dissolved in it, you've made it more dense. You've put more matter into that area, so it's more dense. So, it's easier for things to float on top of that. So you'll have that separation, and then a golf ball will sink in normal water, but it floats in salt water because, again, salt water is more dense. So the golf ball's density is less than whatever it is for salt water, so it floats. So when you put the two together, it kind of looks like it's hanging in the middle there. And then this thing is kind of just, taking that a few steps further. But notice the densities of all these, these liquids. The lightest, the least dense is at the top, the most dense is at the bottom. And eventually, everything below the oil would mix eventually. But some of these, it might take a while, but you can kind of see the soap and the water starting to mix already. And this isn't something that you could shake up and then have it return to these layers. It would just turn to 2 layers, these bottom 4 and then the oil. And this, again, kind of takes that another step further, but it also adds in solid objects. So based upon their densities, they'll sink through some layers, but they'll float on others. So it's kind of hard to see the dye. Like if you roll dice, just one single one, it's kind of hard to see, but it's in there, floating on the maple syrup. All right, so the way that the density relates to earth science and its importance is because of the earth layers. Because of density and the differences in density, that's why the earth has layers and why the earth's layers are arranged the way that they are. So when the earth was completely molten, everything was liquid, all the metal, all the rock, everything was liquid. The most dense materials, being the metals, sank to the bottom or the center. So that gives us the inner core and the outer core. Then the other materials that weren't as dense, like the rocks and things like that, essentially floated on the surface. So then as things started to cool and harden, then these layers kind of more set. But the main kind of takeaway is that the differences in density led to the different layers. And the same thing applies with air in the atmosphere. Just like everything else, gravity is pulling air molecules towards the center of the earth. If it can't get to the center of the earth, then it just goes to the ground. But there are more air molecules closer to the surface of the earth than there are higher up. If you've ever heard the term or phrase, that the air is thin at a higher altitude. I mean, it is. There are just less air molecules. There's less oxygen to breathe. So if you go up to a really high altitude quickly, then there might be a period of time where it's difficult to breathe. You feel like you can't catch your breath because your body's used to the amount of oxygen at a lower altitude where there's more of it. So if you go up to a higher altitude, your body is working harder to try to get more oxygen. All right, and then this last little one. So using this density equals mass divided by volume. It's the mass and the volume. Does anybody have calculation?
Trying to find like a number and shit. I'm already know.
Do what?
They would literally call the police real tough. Dang.
All right, so guys, let's mute the microphones. Does anybody have the density value for this one? And feel free to use a calculator. You don't have to. Do it in your head.
2.7.
Nice.
So I write that down in my notes.
Yeah, so you can type in 2.7 there. What about the next one? Does anybody have the next one?
2.7. Would I put that?
19.3.
What did he say?
Good. 19.3.
2.7.
What about the next one?
19.3. Is that it? What do you say? 19.3.
What about the next one, number 3?
$7.87.
Good. 7.87. What about the last one?
$11.3.
Excellent. All right, so all of these things, all these samples, they all have the same volume, so they're the same size. They obviously have much different masses because they have different densities. And then these are the actual metals that these are the actual densities of these metals. So this first one is aluminum, not a very dense metal at all. I mean, we're all familiar with aluminum, aluminum cans and that sort of thing. It's a pretty lightweight metal. Second one is gold, which is extremely dense. There aren't very many metals that are more dense than gold. I mean, there are some, but not very many. This one's iron. And this last one is lead, which is also extremely dense. Does anybody have any questions on any of these? Any slides I need to jump back to real fast? All right, so I have one more little thing. If we jump to, or think about, so this one with the, with water, if something has a density greater than water, it sinks. Something with a density less than water, it floats. It doesn't only work for water. Any sort of liquid, it works with. So I have a little clip of, I don't know, I think it's kind of a cool clip. This guy is floating something in mercury. If you're not familiar with mercury, it's a metal, it's an element that is, it's actually a liquid at room temperature. So it's pretty cool stuff. It's also very toxic. It's not something you want to be around at all. Negatively affects your nervous system. It's not something that if you touch it, it's going to instantly kill you or anything like that. But like I said, it's certainly not something you want to be around if you can avoid it. So let's see. So yeah, so maybe. All right, so like I said, it's kind of cool. You wouldn't expect this thing to float.
We got a nice little breeze today. It's perfect weather for this.
What?
It's not too hot. Sun's pretty bright.
And notice that he has this stuff in, like in a tub, but then that tub is in a tub.
Despite it getting lots of views, it didn't actually work. So I wanted to try again. So I got a much smaller anvil here. Of course, I'm kidding. I got a much bigger tub of mercury. So this ought to get that anvil afloat. This is much easier. Get a little bit more wiggle room. Oh. Also, standing there too long, it cuts the circulation off to your feet.
Oh God.
My feet are tingly as it goes back. There's no mercury sloshing in there, so I know they didn't wait. Let's, I got this rag wet. Let's wipe off the top. Get all that oxides and stuff off of there.
So as the mercury
Isn't that
reacts
pretty?
with the air, that's what's creating those oxides. It's kind of like a tarnish.
Since the rag's wet, it sticks right to it. Don't get all of it, but it's a lot better than it was. All right, so here's my 110-pound ironworking anvil. I think we got this for making horseshoes and stuff back when we had horses. So let's set it in here and see if it floats. Okay, it doesn't seem to want to stay upright. I'll just let it tip over. There it is. It's floating. Look at that.
Pretty crazy.
The iron anvil floats because mercury has a density nearly twice that of iron. In fact, due to the density ratios, the iron actually floats better than wood does in water.
Sunday. Let's push it down. Oh, it's hard to push down. Oh, that was great. Here, let's try it again from the other side. Okay, here we go. Push down. Bobs up like a cork.
Mercury's really weird stuff. I mean, you see it move like a liquid, but it doesn't make stuff wet like we think liquids should, because that's what we're used to seeing. Yeah, it's really weird stuff. But it's kind of cool. Yeah, I mean, you can, Google it. There are a bunch of videos on it and that sort of thing. So yeah, but it's all because of density. I mean, it doesn't matter the material. If you have a liquid that's more dense than that material, you can, it'll float in that liquid. So are there any questions or slides I need to hop back to?
Yeah, excuse me. Can you go back to the third slide, please?
Which one was it?
Uh,
That one? Wait, whoops.
the definition of density. Yeah, thank you.
Okay. Are there any other ones?
Can you go back to the last one?
The very last slide?
Yeah. Okay.
Any other slides I need to go to?
I have a question.
Yes.
How do you submit this?
You don't submit this. This is yours to keep.
Oh, so it automatically saves, right?
Yeah. So you can just save that into Google Docs or Google Drive or whatever it's in. You can save it, and this is yours to keep, so you have a copy of the completed notes.
Thank you. I will do that.
Mr. Strom,
Yes.
for it to save, would you just close the drive and it will save automatically?
I don't know if it saves automatically. I mean, that's where I would save it to. Save it to that, and I mean, it should. Like I said, I don't know if it saves automatically, but that's definitely where you want to save it to.
I just figured out how to save it.
Cool. Anybody else? Okay.